Hey guys, highlights from video number 1. This is a stat 1150, and just a few highlights very quickly from the first video. The focus on this class in statistics, which is the science of collecting, analyzing, and interpreting data, is data and variation. And for now, what I want you to think about when we talk about variation with data that we've collected, it's just the spread. How much spread is there? And if you watch the video, the first video, which you should, it's required, you should have noticed that one of the examples is we had 3 exam scores over, hypothetically 4 different classes. The first exam scores were 80, 80, 80, in which case there was no spread, no variation. The next 3 scores were 79, 80, 81. Well, it had more spread, more variation than the 80, 80, 80, but not as much as 70, 80, 90. So that's really all I want you to know right now. We're going to build up on this throughout the class. But something else I approached was different types of data that we could collect. And we talked about categorical variables, which are also known as qualitative. And we talked about numerical variables, which we call quantitative. These things are relatively straightforward as long as you keep it simple, I guess. Categorical variables: gender, political preference, religious affiliation. Numerical variables, example of that would be your ACT, the number of pets that you own, your height, your weight, your height in inches, your weight in pounds. This only gets a little bit confusing for students in the beginning when we implement coding. For example, it would be completely appropriate. In fact, I would prefer this if I was running something called a logistic regression model. It would be completely appropriate to code a categorical variable numerically as 0s and 1s. So guys, just because you see numbers doesn't mean it's necessarily a numerical variable. This case right here, it would clearly be categorical. All right? Now, one of the most important things that I wanted you to take from the first video is once we have our data and we've classified it as either categorical or numerical, what do we do next? Well, what we do, and this is a Darbroism. I don't think you're going to find this in any textbook. We would want to statistically describe the variable, the data that was collected. Well, it turns out, depending on whether or not we have a categorical variable or a numerical variable. So guys, I got to tell you, I'm used to calling this qualitative and quantitative, but your book calls it numerical and categorical, so I'm having to change. So if it slips out and I call it quantitative, just overlook me. But if we're going to statistically describe a categorical versus a numerical value, again, numerical, these are numbers. So the thing we'd want to look at here would be averages, something called a standard deviation that we'll talk about soon enough. We'll talk about something called a median, different things like that. Categorical, on the other hand, these things don't, you can't use arithmetic there, so you can't add them up and divide by how many you have, so averages aren't appropriate, and neither would standard deviations or medians, because you can't arrange these things from low to high. So it works out pretty nicely. When we have categorical variables, all we look at is just the frequencies and the percentages. So, for example, to keep it very straightforward, if I have a class that has n equal 20 females and n equal 30 males, then I have 50 total. I guess this, let's try to get the focus a little bit better. That was kind of annoying me. All right, I think that's better. So we have 50 total students. So if we're statistically describing gender, we would just, again, report the frequency. And we would report the percentage. So males equal 30. So we would have 60% of males. Don't you wish the class stayed this easy? It does not. Now, sometimes we not only have one categorical variable, but we have two categorical variables, and we want to explore the relationship between the two. Well, as I showed you in the previous video, what we do sometimes is use a contingency table or a 2x2 table to represent that. For example, if we have a bunch of students at Shawnee State University, and we have male versus female, and then maybe we have some sort of beliefs, politically, Democrat, Republican, let's just say that we classify everyone as one or the other, then it would be reasonable to come in and look at a 2x2 table. All right? So that's kind of the purpose of this video, is to show you how we do this on our statistical software package called R. Now guys, it's getting ready to get down and dirty here. It's getting ready to get pretty heavy stuff. I'm going to show you how to go into Blackboard and get a data set that I posted, save it to your desktop, open it up in R, and actually perform this analysis. So got a lot going on here. So if you're having a hard time focusing, you may want to pause, come back later. Because guys, you can make the simplest mistake and it can drive you insane if you're not totally on board with me here. All right? So now that you're scared you to death, let's go to our Blackboard site. And what I want to do here, for some reason I'm not able. Here we go. Let me get rid of this. What I want to do is I want to go into. Well, I'll tell you what. First thing I want to do is download R. I uninstalled it. I don't know why this is showing up down here, because I uninstalled it because I wanted to demonstrate to you in this video how to install R. So finding R is really easy. I would just go to Google and just type R. And the first thing that will come up will be the R project for statistical computing, and that's what you need, okay? Now, the newest version is R 3.30, supposedly for educational reasons. But I'm not going to go there. I'm going to go right up here to where it says to download R, please choose your preferred crayon, C-R-A-N, mirror. So I'm going to click download R. And I'm going to scroll all the way to the bottom and get our crayon. And guys, the one I want you to use is the third one. It's stat.ucla.edu. I like those guys. I've never met them, but they do exceptional work. I don't really think there's going to be a tremendous amount of difference in any of these, but to keep things consistent, let's choose UCLA. So I'm going to click that, and the next thing I do is I come to this screen where it says download and install. Well guys, I'm working on a Mac here. If you're working on Windows, choose this. If you're working on Mac like me, then you're going to see exactly what I see. So I'm going to click Mac, and the one that I want is this 3.30 package. Okay, so it's the recent one. Makes sense. Let's do it. Now you can see where it's downloaded, and it's going to take a few seconds for it to complete the download, which I am going to get a cup of coffee while this happens. I should start playing some music, shouldn't I? Alright, 12, 11, 10, 9. Alright, cool. Now, if your internet speed is a little slower than this one, I'm doing this from my office, and this is much faster than I would get at home. Just pause the video. That's a great thing about taking a class online. Whatever happens, pause the video, come back, it'll be here. All right, guys, I'm going to install this. I'm going to go continue. I'm going to trust that that's all above board. It is. I've done this before. I'm going to agree to everything. And I want to install for all users of this computer. So I'm going to hit continue. And I'm going to hit install. And I'm going to type in my password for the computer, which I did. And really, once you get this thing downloaded from the internet, it really doesn't take long to set up R. Well, it's proving me to be a liar. Well, it should do pretty quickly. I thought about just going ahead and having this installed and just cut to the chase, but what I have found is the installation process of R seems to give some students problems. I'll tell you what, let's do. Let's have some fun while we're waiting. First quiz. This is what you got to do. Quiz number 1. This is what I do when I get bored. Quiz number 1 worth 20 points. Tell me something interesting about you. Well, it would probably help if you could see that. All right, tell me something interesting about you. To get your credit, 20 out of 20 points, you need to send an email to me. You should know this by now. Talked to a person one time. They took an online course from me, and they said, well, I never check my email. So you're taking an online course and you're not going to stay in touch with me via email. If that's the case, you need to drop immediately. This is just not this is not for you. You're not ready for an online course if you can't do something as simple as check your email daily. So guys, send me an email here in the subject line. I want you to put quiz number 1, stat 1150. And then in the body of the email, tell me something interesting about you. Hit send. I'm going to give you until the first homework assignment is due. And after that, I'm not going to accept any more of these. So if you do that, you get 20 out of 20. If you don't do that, you get 0 out of 20. So that's quiz number 1. It's called one of Darbro's goofy quizzes. I do this stuff all the time, even when I'm teaching in class. So okay, guys, looks like the installation was successful. I'm going to close that. And you notice down here on the bottom, at least for me, I have the icon. So I'm going to click that, and I'm going to open up R. All right? Now, the first thing I have to do is I have to go get my data. And I'm going to go get this data from something that I've already uploaded to Blackboard. Okay? So if I go to our site, which is 1150 summer. Now, if you're watching this, I'll probably use this video for future classes. So you might say, well, I'm not taking the summer class. Okay, implement an ounce of common sense there, people. Go to the classes that you're currently taking with me. But nevertheless, you'll go to content, probably under week number 1. Now then, again, I'm teaching this class, putting this video up in the summer. Summer started May 23rd. Maybe you're taking it in the spring, and week number 1 was January the 8th. So week number 1. And what you'll see a data set for video number 2. So I'm going to click that, and I want to save it. And I'm going to open it up. And you can see what I've got there. Let me make it a little bit larger. what I've got there is I've got a data set with some IDs, party, this should be Democrats and Republicans, belief, gender, and then just some random scores. Now the data set that we looked at in the first video was small and manageable. I think there were only like 15 cases. Well, boys and girls, if you go all the way to the bottom here, you'll see that we have 880 subjects in this data set. So this isn't something that I could just kind of look at and get an indication of the relationship between, for example, party and belief. Party, again, Democrat, Republican. Belief is pro-life or pro-choice, and gender is either female or male. I can't look at that and determine much. So what I want to do is I want to get this data into R and use some things that I'm going to show you how I can actually examine the relationship between some of these variables. All right? So the first thing I want to do is I want to come up here and do a save as. And I want to save this as party, belief, gender. And I want to save this to my desktop. The reason I want to save it to my desktop is I'm going to program R. I'm going to instruct R to go to the desktop to get this file. It doesn't know which directory that you want it to go to unless you tell it. And I've found it's easiest if we put this on the desktop and go from there. Your file format should be comma separated values.csv. There's some other ways you can go into some goofy stuff here, like Windows, comma separated, and that's not what we want. We don't want the MS-DOS, comma separated values. We just want comma separated values.csv. And it's something similar to that on Windows, okay? And I want to hit save, and it's going to save it to my desktop. Now, it's going to tell you there's all sorts of features that are going to cause errors. Don't pay attention to that. Just hit continue. And then let's close this down because we don't need it anymore. And we don't need to save it because we've already saved it. Now, if you look on my desktop, I've got this .csv format here called party, belief, and gender. So I want to go get that. So the first thing I have to do is I have to tell R that, let me get this a little bit larger. I have to tell R that I want it to ignore all other directories on my computer. I want it to go to the desktop. So the first thing I've got to do is I've got to ask R in what form, in what format do you want this to be entered. So I'm going to get my working directory and get the format that it wants me to use to set a new working directory. And I can see that I have this in terms of backspace, users, ddarbro. And guys, yours might have, after your name, it might have a backslash there, and it might have like documents or something like that. So ultimately, when I set my working directory, I want to follow this. And I want to go just like it says. But after my name, and again, you could see documents there, you could see downloads, you could see all sorts of different stuff. I want to replace that with desktop. Now, a lot of times in R, people want bells and whistles when you do something right. It's not going to give you bells and whistles like, great job, you did good, nothing like that. It's only going to tell you when you mess up, which by the end of the day we'll probably do quite a bit. Now the next thing I want to do, I have a .csv form, a .csv file, so I want to go get it. So what I'm going to do is I'm going to call my data. So that's what it's going to be referred to once I get it into R. But I got to go get it, and I'm going to use what's called the read.csv command in R. That's going to go read a file that's in .csv format, and it's going to save it to R under the heading of data. Now I've got to, in quotations, the name of the file I'm trying to get over here, if you see where is party, belief, gender. So I have to type that exactly. Like it says. Now I want to mess up. Let's say that I do this. Now you and I see that as the same thing. We see gender capital G and gender lowercase g as the same thing. R sees that as Venus and Mars, two completely different planets. Now when I get this, it's not going to work because I'm going to get an error because I've got it typed in correctly. Okay. I just lied. I don't believe. Okay. Let's see if. Well, I'll be darned. I am not understanding that. That usually never works. Okay. Guys, I'm stumped. Typically, if you have a capital G where your file name is lowercase g, typically it won't work. Okay. Maybe this new edition, supposedly educational, realizes that a lot of students make mistakes with uppercase and lowercase, and it's corrected that. I have no idea. I am absolutely stumped. Okay, well, let's go for it. But don't get in a habit of that because I don't think that's going to work all the time. All right, guys, I'm done. I'm still stumped. Now, once we get our data saved into R, we still can't do anything with it until we attach it. So I have to attach data. Now, and again, this file is named Party Belief Gender when it's on my desktop. This file is named Data when it's in R. So it's in R. I want to attach it to the frame, if you will, to where I can actually do some statistical analysis. Okay? So I've attached it. I'm good to go. Now, let's say, for example, I would like to explore the relationship between I don't know, party and belief. So what I want to do is I want to get names of my data, and what this is going to do, it's going to tell me the way that the variables are coded. So notice I've got capital P. Now, if this thing isn't uppercase sensitive, then maybe, I don't know. Let's see if it is. But to create a table, like I showed you in the first video, I would just do table and then the arrow. So I'm going to do something over here to the right, and I'm going to save it as table. And I'm going to use what's called X tabs. I start out with a tilde. Guys, that's up in the upper left-hand corner, right below the escape key on a MacBook that I'm using. And I want to, I'll tell you what, I want to try this out. I want to do party plus belief just to see if this is gender, or if it is uppercase sensitive. Okay, so apparently what's going on is you can pull in a file, not necessarily case sensitive, but you can't, see right here it says party not found. It doesn't find it because party is capitalized. Now, all I have to do is hit my up arrow, and it will bring the next, that row that I just typed down. And then I can come in and correct this and understand that this is case sensitive and have party plus belief like I have right here. Okay? Now, I'm not going to get in here this time. So now I have my table, and most people want some bells and whistles. They're like, well, I did this, and it's got to be correct because I didn't get an error. Why am I not seeing my table? Well, you got to type table to see your table. Okay? So now we've got a 2x2 table. Whatever you put first in your X tabs, that will be your row, and whatever you put second, that will be your columns. So we can see of the 880 participants in this that 400 are Democrat, their belief is pro-choice. 150 of the Democrats are pro-life, 80 of the Republicans are pro-choice, and 250 of the Republicans are pro-life. Now, we'd probably want to investigate this a little bit more, maybe by looking at row totals and row columns. So I can do that by going add margins for my table. Now this is kind of clever because what this will do, it'll give me my sum. So I have 550 Democrats, 330 Republicans. I have 480 people in this study who were pro-choice, and I have 400 who are pro-life. Which one of these would you fall into? Would you be part of the 400, part of the 150, part of the 80, or part of the 250? I know where I would be, but I'm not going to tell you because I think that's tacky for a professor to promote his or her political beliefs. Now, another way of doing this, if we just want like the sums, again, we're working with this table, right? And table always takes me back to the way it was originally saved. But I can also do something called margin table. And I got to tell what table I'm wanting to do this with, because I could have 5 or 6 tables. And if I do a table 1, watch what we get. I just get the sum of the rows. Now it's probably, this back here is more comprehensive. It takes care of it. Wham, bam, thank you, ma'am, you're done. But if you just want the row totals, you can do margin.table 1. And if I want the column totals only, I can do table 2. Then we get the 480 and the 400. Now, sometimes you want proportions. In other words, of the 880, how many are pro-choice Democrats? Well, I could just go up here and say, well, I want 400 divided by the total 880. And I could see that 45.5% of the people in this data set are Democrat pro-choice. Well, how many Republican pro-life do we have? Well, I have 250 divided by 880, so I have about 28% of those in this data set, in this sample, are Republican pro-life. Now, kind of a cool way to do this and get all of it is called prop table. And what that will do, it'll give you the proportion of the individual cells. So we can see that 45.5% are Democrat pro-choice, which aligns perfectly with what we calculated earlier, and 28.4%, as we saw, are in the bottom right-hand cell, which would be Republican pro-life. Now, guys, if we only want the row percentages, what we can do is we could go up to table, and all we have to do is hit just comma 1, and then all this will do, it'll just give us the row proportions. Now, where do those proportions come from? If you look at this first row and look at the total, you have 550 Democrats. 400 of the Democrats are pro-choice. So 450 out of the 550 are 72.7%. That's where that comes from. This 27.3% would come from, again, we're looking at rows, so it would be 150 divided by 550. This would be 80 divided by 330. Okay? So 80 divided by 330 would give me my 24.2%, which is that right there. If I choose to look at things from columns, like 400 over 480 would be the percentage of Democrats who are pro-choice. Well, I should say, of those who are pro-choice, what percent are Democrats? Then I could do the same thing here, but do the columns. So, clever ways to get this done. So that would be equivalent to me coming up here to the original table and saying, well, of those that are pro-choice, 400 out of 480, so 83.3% are Democrat. So, guys, it's a clever way to do some stuff in R. We use our calculator a lot, but calculator doesn't have handle categorical variables. It can't create a 2x2 table like what we can do in R. So, guys, you're going to have to get R downloaded and get relatively comfortable with it. Now, let's just say I want to look at, instead of looking at the relationship between political party and well, I don't really need to go up. I can just look at the names. So instead of looking at between party and belief, I'd like to look at gender and party. So what I would do is I'd create another table, but I'd call it something different. So I'm going to just go call this table 1. And I would use X tabs. And I would like gender to be on the rows. And I would like party to be on my columns. Now if I do table 1, I can see that I have a breakdown of gender across political party. If I want my proportion, if I want my row totals and column totals, then I would use add margins. But I want it for table 1, not just table. And I would see that I get my sums. So there are 450 females. There are 430 males. There are 550 Democrats, and there are 330 Republicans. Guys, I could still do the prop table, but just use table 1 here instead of table. So, guys, this is really easy to do. Now, again, keep in mind, we can put the combinations together. So, if I need to communicate to you here, I can use a hashtag, and this allows me to create a question or type something to you. If it doesn't have a hashtag, it's looking for an R command. So I might say, what percentage of women are pro-choice? Well, how would I do that? Well, I need to create a table. I'll call this table 2 with my X tabs, tilde. And I need what? Gender and belief. Now, I want my sums. And I can see that what percentage of women are pro-choice. Well, there's the women. And what percentage are pro-choice? It would be 246. So I could just say the 246 out of the 450 women. So 54.7% of women are pro-choice, whereas 204 out of 450. Now, another question would be something of all subjects. Of all the subject, what percentage of women, are pro-choice? So guys, there is a situation where you get into your prop table. And you would say that of all the subjects in this sample, that 27, well, actually this would round to 28.0%. Or 27.95%. So of the sample data, 27.95% are females who are pro-choice. All right, gang. That's about all I got. I want to show you one more thing. I started out this video telling you that there's a difference in the way that we approach categorical variables. It's okay. There's a difference in the way we statistically describe categorical variables with numerical. And if you look at the variables, again, we get that by names data. We can see that ID would be categorical, party, belief, and gender would be all categorical, but scores would be numerical. Well, it turns out that if we want to find the average of scores, all I have to do is type mean. Now, here's a situation that if I type mean, again, you and I see mean, capital M, lowercase m, the same thing. This is a case where R is, as I expected earlier, to be case sensitive. We'll learn something about a standard deviation, so very quickly we can get the standard deviation, and if we want a nice histogram of scores, we can see that we can create it that way. You guys probably have seen a box plot. We can create a box plot. So guys, more to come about statistically describing numerical variables. But right now, this video, the main focus was on looking at categorical variables in two-way tables. So guys, I'm done. Have a good one. Don't forget to get me that quiz. That's 20 points. Those things, they add up, because there's going to be, I'd say there'll probably be about 5 of them. So be on guard. All right, I can't wait to see who gets it to me first. Take care.